Welcome back to Containers from a Cruising Altitude. My name is Ben Rasmussen, and in this section we are going to be exploring container orchestration. In the previous section, we talked about container runtimes, and container runtimes are going to be excellent for when you want to build or run a single container or a small number of containers. But you're going to want to start exploring container orchestration when you want to think about managing 50 containers or hundreds or thousands. And so we're going to start this section by looking at container orchestration from a cruising altitude. I had to do it once during the presentation. So container orchestration abstracts the where, the when, and the how to deploy your containers. And this can be done at a small scale or a large scale. So an example of small scale container orchestration will be something like Docker Compose, where you can manage multiple images and configurations in a single file. So in that file, you might define the images that you want to turn into containers, perhaps some network configuration, so how those images and containers are going to talk to one another at runtime, and maybe add in some volumes, so storage mounts that the containers can use at runtime. And then you can manage all of those containers all at once using Docker Compose, primarily a Docker Compose up, which is going to bring all of those containers up at the same time, and Docker Compose down, where you can bring them all down at the same time. Another example of a small-scale container orchestrator would be Podman. So in the previous section, we briefly touched on Podman, and I mentioned that one of the things that sets it apart from other container runtimes is that it has a built-in container orchestration. And it's going to do that with the concept of a pod. So you can define, again, in a configuration file, how you want your containers to be deployed, and if you want them to be deployed together in a small group together. And that group is then kept alive by a container called an infra container, which is specific to Podman. And Podman will allow you to deploy multiple pods or multiple groupings of containers, and you could choose whether you want that to be application-based or service-based. So if you want all of your web applications deployed to a single pod, or perhaps your web application, its load balancer, and a Postgres database or something to go with it. This section isn't going to focus on small container orchestration. This section is going to focus more on large-scale container orchestration. And in particular, we're going to talk about Docker Swarm and Kubernetes, though there are other large container orchestrators. The popular one that I know of that we're not going to talk about is Apache Mesos, which is one of the oldest container orchestrators. But large-scale container orchestration is going to help cluster multiple servers or multiple clouds into a single view and allow you to automate some orchestration tasks. In particular, you're going to be looking for deployment automation. So being able to say, I want to start up 50 of this type of image and turn those into containers. Availability and health monitoring. So container orchestration commonly has some type of availability monitoring built into it. So if a container disappears or if the application enters an unhealthy state, it can destroy that container and create a new container in its place. Many container orchestrators have application scaling built in, both horizontally and vertically. So horizontally, building additional containers when needed, and vertically, building beefier containers when needed, be it CPU, RAM, whatever. And container orchestrators also commonly help you load balance across infrastructure. And this goes back to what I was just saying, where large-scale orchestrators will cluster multiple servers or clouds into a single view. So if you want to deploy, let's say, 10 web applications, a large-scale container orchestrator might distribute that across multiple data centers for you or multiple clouds. The first orchestration software we're going to talk about is Docker Swarm, and with both of these orchestrators, we're going to talk about architecture, which is going to be more of just a high-level terminology of the orchestrator, and then some features that we can compare and contrast these two with. So Docker Swarm uses a manager's workers model, which is going to be very similar to a master-slave style model. The manager is going to receive tasks, or I should say receive commands from the user, and dish those commands out to individual workers. Commonly, the workers are going to be given image creation tasks, so create or take an image and create a running container, and those containers are deployed, and when they are deployed, they are called tasks with Docker Swarm. Docker Swarm and most basic container orchestrators will have this concept of a service, which is going to be a persistent view into an application. So what this does is it abstracts away the containers running from the user's view. So if you want to access a particular application, you'll normally go through the service, and then it doesn't matter what containers are running behind the service, whether you could be upgrading and swapping out containers could go missing, whatever. The service is a persistent view into that running application behind it. And then Docker Swarm has a key value store. Commonly, this is Zookeeper, and that's just going to store things like state of the swarm and perform some basic service discoverability. Service discoverability, for the record, is the ability to automatically detect when a new application is deployed and it has a persistent view, that service, in front of it. So you don't need to manually inform the swarm that this new service is available. It should just become automatically available for you. So some features of Docker Swarm. The biggest one is its easy setup. It is one command, Docker Swarm init. And you can do this even with something like Docker for desktop to help you mimic what your production environment might look like. So it's very easy to do testing with Docker Swarm, because with that Docker Swarm init command, you can just turn your laptop or desktop or whatever your development machine is into a manager and a worker. You deploy containers using Docker Compose files. So if you already know the general Docker terminology, I guess, or the Docker command line, you're already fairly well prepared to use Docker Swarm. And again, with Docker Compose, a lot of people are going to use that for development purposes as well. So you can just use your development files essentially and feed them directly into Docker Swarm to create your running containers. Another bonus of Docker Swarm is that it has built-in traffic encryption. So any information that's sent within Docker Swarm's internal networks is encrypted by default. A couple of cons to Docker Swarm. You need to use third-party monitoring. They do have open APIs, so there are tools that do interface with Docker Swarm, but there's no kind of standard or de facto tools to use with the Swarm. And the biggest downside, especially when it comes to doing things in production, is that Docker Swarm uses manual scaling. So there is no automated horizontal or vertical scaling in Docker Swarm, and you end up having to write wrapper scripts to do so. And I mean, just through some basic research, the wrapper scripts commonly are not trivial. So you need to be kind of maintaining your own scaling when it comes to Docker Swarm. Then you have Kubernetes, and Kubernetes is absolutely huge right now, almost to the point where it's almost the Docker of container orchestrators, where Docker is kind of the de facto go-to for container runtimes. You'll hear Kubernetes all over the place when it comes to container orchestration. And you see up at the top here, we have Kubernetes and then in parentheses K8s. K8s is a very common abbreviation for Kubernetes, which is a K, 8 letters, and an S. And it's to the point where even if you do your Google searches with K8s rather than Kubernetes, you're almost always going to get the correct results. As far as architecture goes, it's going to be a very similar model. You have master minion in this case. It's really just a change up of terminology. Masters tend to be distributed in Kubernetes because Kubernetes tends to be deployed in a large scale environment rather than just like a Docker Swarm where it's commonly just a small environment for development. It is worth mentioning that Docker Swarm can also be deployed with multiple masters in failover. You can fully productionize Docker Swarm, but it's a little less common. And similar to Docker Swarm, your masters are going to receive commands from the users and dish those commands out to the minions. The minions will then take those commands and execute them, commonly image creation. And when they create images, they create the concept of a pod. This is different than a podman pod. So with podman, a pod is just a logical grouping of containers. In Kubernetes, a pod generally maps to a single container. And that's even recommended in their own documentation because a pod is going to help isolate that container from other containers running. One instance they do say it can be okay to run multiple containers in a pod is if you are doing something like converting a legacy application into a containerized application and you haven't had a chance to split everything out yet. Then in the Kubernetes documentation, they do mention that it's okay to deploy multiple containers in a single pod if you're not quite ready to fully split everything apart yet. Similar to Docker Swarm and, again, other orchestrators, Kubernetes has services that get deployed to provide a persistent view into your applications regardless of what containers are running. And Kubernetes also has replication controllers, which is going to loop into our scaling that we'll talk about in the features here. So with the features, the two big ones for Kubernetes, built-in monitoring hooks, very easy to add monitoring into Kubernetes. Commonly, you use an Elk stack of some kind, which is your Elastic, Logstash, and Kibana stack. Prometheus can be used very easily to monitor the health of your cluster, and that can also be used in your auto-scaling. And Grafana is commonly used to monitor the containers. When it comes to auto-scaling, you really have kind of free reign on how you want to define how your cluster can scale. So horizontal scaling wise, if you know that you're going to have 10 times the amount of traffic at noon for your web application as you would at midnight, you can have any number of hooks monitor that traffic. So you can have hooks that are going to monitor CPU load and build yourself beefier containers when your CPU load gets too high. Same with RAM usage. You can say if the network traffic increases to 150% of average, spin up an additional 10% of containers or something. So the auto scaling with Kubernetes is one of its coolest features, and it's very, very well fleshed out. Some downsides to Kubernetes is that it uses its own CLI, and in fact, I believe it's split up into two separate CLIs, kubeadm, which is kube administrator, and kubectl, which is kube control. And even around those two, there are a series of third-party wrapper scripts that people have built just to kind of help with some basic convenience tasks with Kubernetes. Kubernetes has a much more complex installation than Docker Swarm. There's not going to be a single command or a single one-stop shop to stand up a Kubernetes cluster. It's going to take a little more research to get that up and running. And if you want traffic encryption internally, you'll need to use some sort of third-party traffic encryption. A cool thing with Kubernetes right now is that AWS is actually rolling out AWS managed Kubernetes. So you can manage a Kubernetes cluster through AWS and kind of abstract some of the difficult installation pieces. So that's all we've got for container orchestration. It is a huge topic, and you could easily do an entire presentation simply on container orchestration. Hopefully this is given a high enough level for now, and in the next section, we are going to move on and talk about container build tools and container support tools.